This video takes a look at sections 13.6 and 13.7, how to divide a polynomial by a monomial, and then how to divide a polynomial by a polynomial. Okay, a monomial is an expression that only has one term in it, and a polynomial is an expression that can have any number of terms in it. So let's look at the example. And this is on page 1 of the 308 notes for sections 13.6 through 13.8. And I guess the example we'll use is number 2 on page 1. And that example is, you have 20 into the 5th plus 8 into the 4th minus 5n squared divided by 4n cubed, and you should rewrite that vertically with 4n cubed in the denominator. And then what you're going to do is divide each term in the numerator by your denominator, which is a monomial. So this is the easy kind of division. One step that you can use when you're beginning this kind of thing is to rewrite like this. So that each term in the numerator is separate with the same denominator as your monomial. And then you can solve each term individually. So in the first term, 4 goes into 25 times, 4 goes into 4 once, and then into the 5th over into the 3 is you subtract the exponents, so you get 5n to the 5 minus 3. For the next term, 4 goes into 8 2 times, and then you have 2n to the 4 minus 3. And then for the third term, you just have 5/4, nothing goes into anything, n to the 2 minus 3. So let's simplify the exponents. 4 minus 3 is 1, and so you can just write 2n. And then you have n to the negative 1. But your expression is not simplified if you have a negative exponent. So our first two terms are simplified, and we need to move that n to the negative 1 to the denominator where it becomes n to the positive 1. And that is your final answer. Now let's look at when you're dividing a polynomial by another polynomial that is not a monomial. Okay, on page 2 of your class notes, you will see 13.7, dividing a polynomial by a polynomial. And before we begin, I want to review doing long division, because we're going to use the same steps to divide polynomials. So we're going to divide 6,697 by 27. Okay, we first look at the two front numbers up here, and 27 goes into 66 2 times. 2 times 27 is 54. So we subtract 54 from 66 and we get 12. We make sure that 12 is less than 27 so that we know we chose the right number here. And then we bring down another number. We bring down 9. So now we have 129, and we have to ask, how many times does 27 go into 129? And it goes 4 times. I'm going to write the 4 in blue. So 4 times 27 is 108. So when you subtract 108 from 129, you get 21, and then you check 21 is less than 27, so 4 is the correct number. And then you bring down the 7 from here. Okay, now we have to see how many times 27 goes into 217. And it goes in 8 times. And we know that 8 times 27, when we multiply it out, is 216. So when we subtract, we get 1. 1 is less than 27, so that's a good number. Now we have nothing else to bring down. So what we are going to do is take this, which is our remainder, and make it the numerator, and make our divisor the denominator, so that we have 248 and 1/27, and that's our answer. Now, one thing I want to go over in the previous problem is how do you check your answer? So to check our answer, we do the opposite of division. We do multiplication, and we find out what is 248 times 27. And then when we find that out, we add our remainder, which is 1. That's our remainder. So 248 times 27 is 6696, and then we have our plus 1, and that equals 6697, which is our dividend, which is what we want. So that's a check of our work. Okay, so now let's turn to page 3 of our class notes, and in the example, the first example, number A, or letter A, we have 6x cubed minus 2x squared minus 2x plus 30 divided by 3x plus 5. And then we rewrite that using the division sign as it's shown, so that our dividend is under the division sign and our divisor is on the outside. Okay, now we're going to follow the same steps for division. We first have to arrange our dividend in descending power order, which it is already arranged that way. So x cubed is the highest power, so it goes first, and 30 is the lowest power, so it goes last. And then if there are any missing exponents, for instance, here's x cubed, x squared, x, and x to the 0 power, which is 1. We don't have any missing exponents. If we had 6x cubed minus 2x plus 30 and we didn't have this term, we would fill it in by writing 0x squared. Okay, once we've done that, now we can perform the long division. So what we're going to do is we're going to look at the first polynomial term, and see how many times it goes into this. So we know 3 goes into 6 2 times, and we write the 2 up here. And we know that x goes into x cubed. You subtract the exponents and you get 2x squared. So what you're saying is, what is 6x cubed divided by 3x? What is your first term in your dividend divided by your first term in your divisor? And so you can see that 3 goes into 6 2 times, so you have 2x to the 3 minus 1, because down in the denominator you have x to the first power, and so that is how I got 2x squared. Okay, now you take your 2x squared and you multiply it by 3x, and you get what you would expect, 6x cubed. And then you take your 2x squared and you multiply it by 5, and you get plus 10x squared. Now notice in our division problem we did that. We had the 2, we multiplied it by 27, and we got 54. What did we do next? Next, we subtracted. So we're going to subtract this from this, and what we're really going to do to make sure we do it correctly is we're going to change the signs and add, because subtraction is the same thing as changing the signs and adding. So when we add 6x cubed to negative 6x cubed, we get 0 here, plus, and then when we add negative 2x squared and negative 10x squared, we get negative 12x squared. You could have just written negative 12x squared and not even had that 0. And let's go ahead and erase the 0 to just give us negative 12x squared. Okay, now we're going to bring down our next term, which is negative 2x, and we do the same process again. How many times does 3x go into negative 12x squared? Pause the video and figure that out, and then come back and check your work. The answer is negative 4x, because negative 4x times 3x gives us negative 12x squared, and negative 4x times 5 gives us negative 20x. Now notice that for my quotient, I'm lining up my degrees. So x squared here, x squared here, x here, x here. Okay, now we remember that we are going to change the signs and add. So we get negative 12x squared plus 12x is 0, negative 2x plus 20x is 18x. So you want to be very careful to remember to do that. Okay, how many times does 3x go into 18x? Go ahead and pause the video and figure that out. Okay, it goes in 6 times. So we have 6 times 3x is 18x, and 6 times 5 is 30. We're going 6 times 3x is 18x, 6 times 5 is 30. And we also want to bring this down so that here we have this. So now we have the same thing, and when we change the signs and add, we get 0. No remainder. So our answer is this. So rewriting the original problem, we have that 6x cubed minus 2x squared minus 2x plus 30 divided by 3x plus 5 equals 2x squared minus 4x plus 6. But what if you're not confident about your work? How do you check that? And we check it the same way we did earlier when we divided numbers without variables. We take the quotient and we multiply it by the divisor, and we expect to get the dividend. So let's do that. And this gives me a chance to review box multiplication. When we're multiplying polynomials together, we can draw a box where it has as many columns as it has terms here. So we're going to have 3 columns, and as many rows as it has there. And you can do it in either order. So here are our columns, and here are our rows. And then on top of our columns, we put each term, 2x squared, negative 4x, and 6. And then for our rows, we put 3x and 5. So what we're going to do is in each box, we're going to multiply the row times the column. So in the first box, we get 2 times 3 is 6, and x squared times x is x cubed. And we do the same thing for each box. And then we after we're done with that, we add all the terms. And then a little shortcut you can use is look at the diagonals. It's not always going to be diagonals, but you can combine like terms and then just write down your answer. So for instance, there's only one x cubed term, so we write 6x cubed. Then we have negative 12x squared plus 10x squared. There are two x squared terms, so that gives us minus 2x squared. Then we have 18x and negative 20x, which gives us minus 2x, and then we have 30. And that's our answer. So when we compare this to our dividend, we see that we have exactly the same thing. So we have done our work correctly, and this is the correct answer, which we got on the previous slide. So now you try it. Turn to page 4 and work number 2 on about mid-page. You can check your answer by looking at the class notes key for this section. Okay, what if you are missing a term so that you don't have every variable power represented like you did in this problem? In part 2 of this video, we will begin part 2 by working a problem like that. So at this point, go ahead and move on to part 2 of the polynomial division lesson.